Project schedules often look best right before they break. On screen, a highly optimized plan looks like this. Every row is filled, the blocks perfectly interlock, and there is zero white space. Project managers often operate under the assumption that this 100% resource utilization is a protective measure. The logic dictates that keeping every team member fully booked shields the timeline from scope creep and unforeseen external risks. But analyzing failed schedules reveals the exact opposite. The practice of plugging gaps with the nearest free hands is actually the primary driver of schedule collapse. Take a look at this graphic from the execution edge. The core issue is a substitution error. Planners are mistaking resource availability for resource capability. A resourcing plan constructed entirely around who has open hours right now is not a strategic plan. It is simply a waiting list with a Gantt chart attached. The cost of this substitution is measurable. The data explains exactly why tasks constantly get passed around mid-sprint. This graphic details the fallout. 58% of task reassignments happen due to picking for availability over skill fit. These mismatched tasks require 3.1 times more rework. Finally, 27% of top performers report burnout from becoming the default for slipping high-stakes tasks. Calendar-first staffing guarantees these compounding rework loops. It mathematically ensures that a tight schedule will eventually break under the weight of its own misallocated assignments. To see the mechanics of this failure, we can examine a plant automation upgrade at Harrow Creek Manufacturing. During the project, a highly complex PLC integration task required an owner. Following standard spreadsheet logic, planners assigned the work to a junior controls engineer solely because that individual had open sprint capacity at that exact moment. The technical mismatch caused the integration to consume 3 times the estimated hours. Management was forced to pull 2 senior engineers from other critical paths to step in midstream and salvage the code. This cascading delay pushed the final commissioning of the plant back by a full 5 weeks. On paper, the planners made 0 errors. The assignment perfectly matched an open calendar slot. This proves that optimizing a calendar is a completely separate function from successfully executing the work. The Harrow Creek failure was driven by underlying assumptions project managers use to justify their spreadsheets, starting with a heavy reliance on generalists. It is mathematically faster to wait 3 days for a highly specialized engineer to become available than to immediately deploy a free generalist who requires 2 weeks to ramp up on the technical specifics. The same faulty logic applies to shared hours. Splitting a critical task between 2 available owners does not double the speed of execution. Shared ownership diffuses accountability. You are left with 2 people, each assuming the other has final decision-making authority, which predictably leads to dropped deliverables. Planners also falsely equate raw hours. 30 hours of critical path work carries significantly more weight and risk than 40 hours of low-stakes work. Equal hours on a spreadsheet do not yield balanced cognitive loads. Managing a project by raw hours and shared ownership concentrates risk. To actually disperse that risk, planners require an entirely different measurement model. This requires moving away from spreadsheet guesswork and toward a multidimensional resourcing model known as the C.A.S.T framework. The C stands for capability. This is a strict filter. Managers must match assignments based on the specific skill required before they ever check an open calendar. The A is for accountability. Diffused, shared tasks must be merged into a single, named, accountable owner to eliminate ambiguity in execution. The S stands for stakes. Raw hour counts are replaced with an impact-weighted scale, allowing managers to measure the true, risk-adjusted workload of every team member. Finally, the T is for trajectory. Top performers are strategically paired with developing talent on high-stakes work. This transfers capability across the team and prevents senior staff from becoming bottlenecks. The C.A.S.T framework changes resource assignment from a static event that happens once at kickoff into a continuous, risk-adjusted matching engine. We can see the mechanics of this framework by looking at how the Harrow Creek team recovered their project. The recovery team immediately scrapped the availability-first staffing model for the remainder of the schedule. They accepted an uncomfortable trade-off, intentionally allowing calendar whitespace. Tasks weeded in a queue for the precise specialist, rather than deploying nearest open hands. The project shipped perfectly on the revised date, executing remaining work with 0 further reassignments. Tolerating idle calendar time and deliberately waiting for capability is the mathematically sound way to protect the overall execution schedule. Organizations that successfully shift to capability-first staffing models see immediate aggregate benefits. Research shows a 64% reduction in task reassignments once skill matching takes priority, and a 41% drop in rework. On-time delivery for high-stakes tasks increases 2.2 times. Furthermore, burnout drops 33%. Risk spreading protects human cognitive load as effectively as the timeline. Schedules do not fail because the engineering work is unexpectedly hard. They fail because the wrong person was standing closest to the work when the task needed an owner.